Hello and welcome back to part 4 of chapter 18, Pressure and Wind, where we're going to talk about El Nino Southern Oscillation, or ENSO. And so I'll give a brief overview of what it is. We'll watch a couple of videos and give you some animations, may sort of highlight what's going on. It has a two components to it. There's the El Nino component, and then there's the La Nina. El Nino means the child or the boy, or in this case, Christ's child. And its name comes from South American fishermen who noticed that during certain seasons you would have better fishing along the coast because of cool waters that were upwelling, and this had to do with the distribution of trade winds along the Earth's surface. So we have an interaction of atmosphere and the oceans here causing this El Nino or La Nina. We'll talk a little bit about the oscillation and what we're measuring, and then some regional climatic implications. The El Nino and La Nina effect are deviations from the norm or from neutral conditions. And so during El Nino, I'm going to come down here to the bottom. What we end up having is a situation in which we have warm sea surface temperatures, and that is primarily those sea surface temperatures sit over Tahiti or the central Pacific Ocean, and that's because we have a slack in the trade wind. So the trades are blowing in right to the west in this direction, and when those are weak, what happens is the atmosphere sort of sits over, or warm sea surface temperatures sit over the Pacific. That creates a low pressure system over that region, so we get a lot of rain over the Pacific, and then that air moves out to the east or out to the west, east or west, and sinks back down. But when it sinks back down, it's actually dry, and so we get wet conditions over the Pacific where no one lives, and it gets dry here and dry out here. Now, the other thing that's happening is with the trade winds. Normally what they're doing is they're blowing ocean surface hot or warm temperatures off in this direction towards Southeast Asia, which allows for cool water to rise up, or cold water to rise up along the coast of South America, and that is not happening. During La Nina, it is the extreme condition in which the trades are strong. So the trades are really strong, and they're blowing all that warm air off towards Southeast Asia, which means you get intense monsoon season, heavy rains, and it ends up creating a high altitude circulatory system which brings dry, warm air back down. So you end up with cool water or cold water upwelling here during La Nina, but it's when the trades are very strong as opposed to being very weak that you end up with then not dry conditions over Southeast Asia, but very wet conditions over Southeast Asia and Australia, and essentially flooding conditions. And this is happening really every 2 to 7 years, something like that. So I thought we'd watch a couple videos, or at least one video here, that will really kind of bring this into focus for us with a few animations.
Hello, and thanks for joining me for the Bismarck Weather Indications in this video on the El Nino Southern Oscillation. Many of you have probably heard about El Nino and even La Nina, but did you know they are simply parts of the El Nino Southern Oscillation, or ENSO? If you like, you can read an official definition of ENSO, but most importantly, remember three key things. ENSO is a relationship between the ocean and the atmosphere. It occurs because of periodic warming or cooling of sea surface temperatures, and it happens over the equatorial Pacific. Let's start with the where. The equatorial Pacific refers to the region of the Pacific between South America, Papua New Guinea, and Australia. Now let's take a closer look at this region under normal or neutral conditions. Strong easterly trade winds blow warm surface water west towards Australia. This allows cold water to upwell along the coast of South America. This is where the ocean begins to interact with the atmosphere. Colder water results in relatively high pressure, and the warmer water results in relatively low pressure. Just like anywhere, with low pressure and ample warm, moist air, there is rising air and thunderstorms. A lot of thunderstorms, in fact. So much that the rising air contributes a great deal to the upper level jet stream flowing back toward South America. It then cools, descends, and starts the circulation all over again. Now for the warm phase of ENSO, or El Nino. Weaker easterly trade winds cause less upwelling along the South American coast, allowing for warmer water to expand further east towards South and Central America. The area of low pressure expands with the warmer water, and the area of high pressure shrinks. Thunderstorm activity expands with the warmer water to the east, which then leads to a shifted upper level jet stream. The cold phase of ENSO, or La Nina, is the complete opposite. Easterly trade winds are much stronger, which confines warm surface water further west and allows for greater expansion of upwelling off the coast of South America. Centers of relatively high and low pressure are shifted further west as well, along with thunderstorm activity being confined further west near Papua New Guinea, once again leading to a shifted upper level jet stream. So now maybe you are thinking, what does all this about the jet stream and sea surface temperatures in the Pacific have to do with weather conditions here in North America? Well, think of the old adage about when a butterfly flaps its wings halfway around the globe, we feel the effects here. Well, think of ENSO as a much, much larger butterfly flapping its wings. When the jet stream over such a large area, like the equatorial Pacific, shifts, the effects of that shift are felt globally. In some places, the change to weather is negligible, shown in gray, but in others, the change can be drastic, shown by the highlighted areas. For instance, the southeastern U.S. can expect a wetter and colder than normal winter during El Nino. Thanks for joining me, and I hope this video helped you understand the El Nino Southern Oscillation a little better. For more on the subject, check out the Climate Prediction Center's website. And for more on what El Nino and La Nina mean for North Dakota, stay tuned to our homepage, Facebook page, and Twitter feed.
All right, so we've got also something we need to focus on here is what are essentially neutral conditions, right? Neutral conditions. Neutral conditions involve the trade winds, trades blowing atmosphere to the west, and also we end up seeing cold ocean water, and we see warm ocean water. Okay, and so everything is compared to and predicted based on what we might consider to be neutral conditions, right? You can have two El Ninos in a year. You can have, in a back to back. You can have two La Ninas back to back. They're not entirely predictable, and so every month a new report will come out from NOAA based on different variables that are involved in making these predictions. So one of those is going to be atmospheric pressure. Right, pressure is something we can measure in millibars or inches of mercury, and that's related to the vertical movement of air. So when the pressure is high over Tahiti and extra low over Australia, we're going to get a kind of deviation from the normal pressure. And when it's high over Tahiti, which is in the central Pacific, and it's low over Darwin, Australia, then we're going to get another deviation from the norm. So we have a neutral condition, and that neutral condition is moving atmospheric or average trade winds blowing warm surface waters over Indonesia, okay, in the area of Australia as well, and then cold waters over here along the coast of South America, okay, and so what we're end up measuring then is the Southern Oscillation, which is the difference between pressures in Tahiti. And there's a bunch of different kinds of measurements that people are making. So Tahiti's not the only place we make measurements, but it's probably one of the most, one of the first places we made this measurement in Darwin, Australia. Okay, so between these two locations, we're interested in the pressure difference and temperature difference of sea surface temperature. So for the Southern Oscillation Index, what are we really measuring? We're measuring the change in pressure between Darwin and between Tahiti. And when that pressure is a positive change, we end up with La Nina conditions strong above the blue line. So the blue line here shows us an index. It's basically a mathematical calculation, and I'll show you. It's a pretty simple one. Anything above this, so all these values here, are going to be La Nina conditions, so we would expect really strong trade winds, right? And then if we're in El Nino, we're below one deviation here below, or one increment below the mean, and we're going to expect El Nino conditions down here. And so we would expect slacking trade winds and warm sea surface temperatures over Tahiti. Right? This is one way we measure this, and that is atmospheric pressure. Okay? Or the difference between atmospheric pressures. So here's Tahiti, right? And here's Darwin in Australia. And down at the bottom, we have the Southern Oscillation Index. This is El Nino in red. El Nino. But we also like to measure ocean surface temperature departures, right, in degrees Celsius. So here's ocean temperature departure. And when it's red, that means the temperatures are high in Tahiti, and that means the trade winds have slacked, and so we have warm water over Tahiti, okay? And then when it's a departure is low, that means we've actually got cool water over Tahiti, and we've got warm waters which have been blown, I should say, over here, over Darwin, and so we're down here when it's when the deviation is negative from the mean, or in the negative numbers in terms of degrees Celsius. And so that gives us La Nina conditions in blue and El Nino conditions in red. So we've got ocean surface temperature we can measure. We've got the Southern Oscillation Index, which is a measurement of pressure, right? So we've got temp, we've got pressure. We also can measure outgoing solar radiation. So outgoing solar radiation from this region is going to be different when there's lots of clouds in the region and moisture in the region than it is when that's missing, and because clouds tend to block or to absorb outgoing radiation and kind of redirect it back to the Earth's surface. We can measure that. We can also measure the elevation of the ocean's surface, because as water warms, it expands, and so the elevation will be a little bit higher in certain regions. So, for instance, Darwin versus Tahiti, and when that water is colder, then it's going to contract or be a little bit lower in those regions. All of those variables will contribute to predicting whether we have El Nino or La Nina conditions. So during La Nina conditions, they're a little bit different across the globe. La Nina during December to February, shown on the top diagram. And what do we expect during those winter times? Well, we see that it's cool and dry here in the Pacific. And why is that? Because we have extra strong trade winds pushing everything off towards Indonesia. And then during June and August, it's really dry out here. Even though that part of the ocean equatorial region should be warm, and it is, but it's warm and dry, and so all that moisture is headed off again towards Indonesia in this direction, and so these are the trades that are doing this. Okay, and so what do we end up with during La Nina during June and August? We're going to expect floods in Southeast Asia. And then, as you noted from the video, we get different climatic effects. So La Nina tends to cause warm, dry conditions during those winter months in the south and southeastern U.S., and cooler conditions as they push in from, and to some degree wetter conditions in the northern part of North America. If we flip over to El Nino conditions, right, now we end up with a situation where the atmospheric moisture, we have weak trades. The moisture hangs out in the Pacific, and it hangs out in the Pacific, so it's wet out here. It's wet out here. Well, in this case, it's dry, but it's because it's in the winter season, and so now down here we're in the summer season, and so it's wet here, but then it's dry in Asia, and so we would expect then to find drought, fire, that kind of thing going on in those regions, and the same is for not just Southeast Asia, but for also Australia. Okay, so El Nino and La Nina conditions are a global climatic effect that is measured and recorded in the Pacific region. All right, so that kind of wraps it up for Chapter 18 and some of the variation that we can see across the globe with regard to pressure driving wind, the movement of wind, both lateral and vertical movement of winds, as well as the global circulation of atmosphere. And then finally, wrapping up with part 4 of this part of Chapter 18, we talked about the Southern Oscillation Index, or the ENSO, El Nino Southern Oscillation, which is occurring somewhere between every 2 and 7 years. And we'll move on in the next chapter, Chapter 19, to talk about severe weather and to try to put together the concept of weather fronts and how fronts produce mid-latitude cyclones, and in some cases can produce severe weather like hurricanes and tornadoes.